And first of all, I would like to thank IASAS board members for giving me this wonderful opportunity to give a talk here. I'm so glad to be here. Well, temporal consistency, test-retest consistency has long been regarded as the gold standard for determining the genuineness of synesthesia. And it is widely reported that synesthetes show stronger consistency in induced concurrent pairings, for example, grapheme color associations, over time than non-synesthetic individuals. And therefore, it has been regarded as an important objective measure of synesthesia, which is essentially a subjective phenomenon. However, recently a debate has been arisen about whether or not temporal consistency is an essential criterion that defines synesthesia. And it has indeed been repeatedly observed that there is a significant link between temporal consistency and subjective experience of synesthesia. For example, in this study by Rotten and his colleagues, self-reported synesthetes showed higher consistency as compared to in grapheme color associations as compared to non-synesthetic controls. However, some inconsistent cases were also found. For example, here are non-synesthetes with high temporal consistency, and there are synesthetes with low consistency. So the question is temporal consistency whether temporal consistency is an essential criterion that defines synesthesia. Several studies have reported that high-low temporal consistency do not perfectly coincide with the presence or absence of conscious experience of synesthesia. And not all the inconsistent cases can be explained by participants' use of a strategy. So such observations call for a careful assessment of the role of temporal consistency in synesthetic reports. So the purpose of this study was to investigate the nature of temporal consistency in grapheme colors association. And to this end, we investigated the relationship between temporal consistency and certain non-regularities of grapheme color associations in the Japanese language. Now let me introduce you to the Japanese language. The Japanese language has 3 types of scripts. One of them is hiragana, which is a phonetic script. That means each grapheme represents a sound. And katakana is also a phonetic script. And Kanji is a logographic script, that is, each character has a meaning. And we also use Arabic digits and English alphabets. And for example, in this Japanese sentence, meaning synesthete A experiences beautiful pink when viewing the digit 4, uses all the 3 scripts and also Arabic digit, and then English alphabet. So Japanese people use all these graphemes in their daily life. So therefore, a great many a great many characters are used in the Japanese language. And typically, Japanese grapheme color synesthetes experience colors for most of all the characters, all these characters. And certain characteristics of Japanese language enable a unique examination of the influence of phonology, meanings, and visual shape on synesthetic grapheme color association. For example, we can isolate effects of one factor, for example, sound, and from those of others like visual shape, using hiragana and katakana characters. Hiragana and katakana both represent the same set of sounds, syllables. For example, a and me, although they look visually dissimilar. And if synesthetic color choices depend on character sounds but not visual shapes, synesthetic color choices will be consistent between hiragana characters and katakana counterparts. And this is what we found. Synesthetic colors elicited by hiragana characters, the upper rows, were highly consistent with those elicited by corresponding katakana characters, the lower rows. And please note that hiragana and katakana represent the same set of sounds, although their visual forms are dissimilar. So the results indicate that color selection depends on sounds and not on visual shape, visual form. In the same way, we examine the effects of meaning using Arabic digits and corresponding kanji numerals. There are kanji characters representing numerals, and synesthetic colors elicited by digits are highly consistent with those elicited by corresponding kanji numerals, although they are visually dissimilar. So we can say that there is a strong influence of meaning concept. And I'd like to add that the synesthetic colors for numerals are determined by meaning but not by sounds. Here are an example of colors for hiragana characters representing the sounds of the numerals. Like, for example, in the Japanese language, number 1 is pronounced as ichi, and here are the colors for hiragana I and chi, ichi, and the colors are not the same. On the other hand, we found little effect of visual shape on synesthetic colors in the case of the Japanese language, and kanji characters sharing the same visual component. We call it radicals, left radical and right radical, do not elicit similar sounds, similar colors. I mean, kanji characters sharing the same visual component do not elicit similar colors. To summarize, although grapheme color synesthesia is characterized as idiosyncratic, that means graphemes do not elicit the same color across different synesthetes, some factors regulate synesthetic colors in Japanese synesthetes with a high degree of inter-synesthete reliability, as there is strong sensitivity to sound and meaning, and visual shape, influence of visual shape is somewhat weak. And such regulatory factors may be brought about by a set of core mechanisms underlying grapheme color synesthesia. So the purpose of this study was to investigate the nature of temporal consistency in grapheme color association. And to this end, we investigated the relationship between temporal consistency and certain non-regularities of grapheme color correspondences. And if temporal consistency is generated by a core mechanism of grapheme color synesthesia, it should co-vary with the strengths of other characteristics shared across Japanese synesthetes, that is, sensitivity to certain regulatory factors such as sounds and meaning. And in the experiment, the synesthetes selected a color corresponding to each of 206 graphemes from a palette of 138 colors. There were 206 stimulus graphemes in total, consisting of 46 hiragana characters, 46 katakana characters, and 53 kanji characters, including 11 characters sharing common right radical visual component, and 9 kanji numerals. And there were also 9 Arabic digits, digits 1 to 9, and 26 English upper and 26 lowercase letters. And the hiragana and katakana characters were used for assess the sensitivity to sounds. And these characters, kanji characters, are for the assessment of the impact of visual shape on synesthetic colors. And these kanji numerals and other Arabic digits were used for to measure the sensitivity of meaning to meaning. And a surprise retest second session was carried out for each participant at least 20 days after the first session to evaluate temporal consistency in grapheme color associations. And the measure of temporal consistency was the mean color distance in the CIE L star, A star, B star color space between colors selected for the first and second sessions, and averaged over all the 206 graphemes. And the measure of the sensitivity to regulatory factors, sounds, meanings, and visual shape, were mean distances between colors selected for characters sharing sounds, meaning, and visual components, respectively. And the scores were averaged over the 2 sessions. And here are the results. The horizontal axis is temporal consistency, and the vertical axis is, in this case, hiragana, katakana consistency, that is the sensitivity to sound. And there were 21 synesthetes participated in this study, and there was a surprising high positive correlation between these two. And for all the 21 synesthetes, the correlation coefficient was 0.88, and when the outlier data were removed, the positive correlation was still significant and high, and the correlation coefficient was 0.69. And we also conducted the same experiment with 32 non-synesthetes who were asked to select a color that intuitively goes with each graphemes. And the results showed that those who were more temporally consistent in grapheme color association were more sensitive to grapheme sounds. And this tendency was more strongly manifested when data from both non-synesthetes and synesthetes were combined for analysis. So temporal consistency was highly correlated with sensitivity to sound. Yeah. And the same was also true for meaning, which was assessed by comparing the colors, synesthetic colors for Arabic numerals and Kanji numeral counterparts. And those with higher temporal consistency were more sensitive to meaning. On the other hand, sensitivity to visual shape was generally lower. The consistency was generally lower. The score is generally large, and did not significantly correlate with temporal consistency. This is consistent with previous findings that visual shape had little impact on synesthetic colors in Japanese grapheme color synesthesia. And also we analyzed the data for English letter, synesthetic colors for English letters. It is known that English grapheme color synesthesia, uppercase and letters and their lowercase counterparts elicit smaller synesthetic colors. In other words, English synesthetes are sensitive to abstract letter identity. And we found that as English synesthetes, our Japanese synesthetes were also sensitive to abstract English letter identity. And furthermore, the sensitivity to abstract letter identity correlated highly with temporal consistency. Let's move on to discussion. The purpose of this study was to investigate the nature of temporal consistency in grapheme colors association. And the results showed that temporal consistency was highly linearly correlated with sensitivity to sounds and meaning, which are known to regulate synesthetic colors in Japanese grapheme color synesthesia. And this observation strongly suggests that a common core mechanism underlies grapheme color synesthesia to bring about both temporal consistency and the effects of the regulatory factors on grapheme color synesthesia. And sensitivity to visual shape did not significantly correlate with temporal consistency, which concurs with previous findings that visual shape had little impact on synesthetic colors in Japanese grapheme color synesthesia. And we also found sensitivity to abstract letter identity with our Japanese synesthetes. And furthermore, the strength of the tendency was surprisingly highly correlated with temporal consistency in grapheme color association. Well, our data do not exclude the possibility that high sensitivity to certain regulatory factors sound and meaning, but visual shape causes high temporal consistency, like in this, like this. For example, that is, synesthetic colors for hiragana and katakana are highly temporally correlated. Highly temporally consistent, possibly because they are strongly regulated by sounds. But we think this is not a problem because the purpose of this study was to investigate the nature of temporal consistency in grapheme color synesthesia. This way of interpretation too provides a new angle on the nature of temporal consistency in grapheme color synesthesia. Note that grapheme color associations could be temporally consistent even if there are no such regulatory factors shared across synesthetes. And this is the last slide. Well, these results suggest an interesting possibility that grapheme color synesthesia may be a spectral condition. The surprisingly high correlations between temporal consistency and sensitivity to regulatory factors when data from synesthetes and non-synesthetes are combined suggest that both groups